Hi grade 12s, welcome to my channel. Let us have a look at this Euclidean geometry question from one of the assignments my students have had to go through. So let's see, and perhaps for them also to see how well they did. We're given two circles with a center A. So this is the big one with the center A, and B. So we can see the smaller circle has center B. Intersect at X and Y. We see that the radius of the larger circle with center A is capital letter R, okay? And the radius of the smaller circle with center B is small letter r, okay? That means BD or BX is small letter r. CX is a tangent to circle B. CX is a tangent to the circle center B at X, okay? And DX is a tangent to circle A, right? Which is circle center A at X, all right? Prove with reasons that the situation below is the case. All right, we're going to go straight into these. So what are we going to see? Well, we see a form of a ratio of some sort where we cross multiplied, it seems. So we know this rings the bells. Oops. Okay, it's doing its things. Okay, it's doing its things. And I don't like these things. All right, let's sort it out. So this is nicely set up for work. Now we know that we may look at two triangles, X, this one, all right, and this triangle. So I'm just going to put the vertices because we can clearly see that for us to get xy squared, it's going to be xy, and it's common to two triangles. Whenever you see a square, this means this side xy must be common to two triangles. So these are some of the clues you need to gather. That once this thing is a square like this, it means this is a common side of two triangles, okay? Just think about it and we look for those triangles. The best ones to use is, in fact, let's just say two named triangles, because this X, whatever that point may be to this one, is not necessarily well named. We may have to give it a name, and that's a different story, as well as this would be if we consider this triangle. So we would have to name it, but these ones are already named in a way because the vertices have names. So we can clearly see here that the key to solving this problem is similar triangles, right? Because that's how the proportionality theorem works. And we have identified our two triangles, XCY and YDX. All right. We will say in triangle. Okay, let me try to be alphabetical. So it's CXY and triangle DXY. Really, the naming is not a big issue if you know what to do. I will show you just shortly. What do we see in these two triangles? We understand that technically CXY, we can see that X1 is equal to D1 in the other triangle. Why? This is the 10 chord theorem, right? Because we're told this is the tangent. So the angle between the tangent and the chord XY is going to be equal to the angle subtended by that chord at circumference. Okay, what else do we see? Technically, this angle right here must be equal to that angle as well, 10 chord theorem. So we'll say C2 to stay consistent to the first triangle and the second. Going to be equal to X2. So this is 10 chord theorem. Now once we prove two sets, normally the third one falls into place. There's no need to really get to it. But if you will, you may want to say it because obviously I see your exams seemingly doing it all the time. So we can just easily say this is Cy Cyx is equal to xyd. These are the remaining angles. One can say sum of three angles of a triangle. Therefore, triangle CXY is similar to triangle DXY. Now this is triple A, okay? Equiangular. Even just two pairs though are good enough. You don't need the third. Don't obsess over going all the way. So this implies that we will have now the sides in proportion. So we can say XY divided by, now we look at XY in terms of the first triangle. Doesn't really matter which one you start with. XY is opposite C2, right? C2 is equal to X2, and the side opposite X2 is YD, okay, or DY. So we're going to say this is over DY. So it's always the sides, sorry, it's always the sides, yes, it's always the sides opposite the equal angles in these similar triangles that make up a ratio, okay? So this is equal to, now our intention is to have this come out. So now we need to select these two angles because we know that for this angle, this side still comes out for the second triangle. So we will see that we're going to choose the side opposite x1 on the first one, which is CY, which is written YC divided by, and then YC is opposite x1. X1 is equal to D1 on the other one, and D1 has this side XY opposite it. So we write that one XY. So for me, can you see the naming becomes very easy to choose the proportional sides or the sides that make a ratio, which is going to be equal to the yet another ratio. Why? Because what makes up the ratio is literally the sides that are opposite the equal angles in the two triangles. So we can just say these are the proportional sides of similar triangles, and we have just spoken about those, and all we have to do now is cross multiplication. We will see that xy squared is going to be equal to dy times YC. Not a very difficult question, as long as you have the strategy as to what to look for and how to look at it. You just go for it without any doubts. So 3.2 says we need to find A1 to be equal to B1. Okay, so this means this situation right over there must be equal to the situation right over there. So how do we get around it? We'll see that we've got this crisscross, some kind of a very disproportionate bow tie of some sort. Technically, this spells out the angle at center, because guess what? We found that x1 to be equal to that angle. And we know 2 times this angle D will give us the angle at the center, and 2 times that x1 gives us the angle at center. And if we replace D1 or x1 in either one, then each one becomes defined by the same angle. And that would mean the two are equal. So we'll start by saying technically we know that angle A1 is equal to 2 times angle x1, right? Now this is angle at center equals to 2 times angle at circumference. Okay? Well, city also, or perhaps likewise, because this is similar, Likewise, we understand that angle B1 is going to be equal to 2 times angle D1, right? Angle at center equals 2 times angle at circumference. Great, so we will say but, or however, we understood that angle x1 has been proven to be equal to angle d1. We can just say proved above. If the argument did not use these two, one can easily just provide the reason that it's the 10-chord theorem. But at this point we have proved it, so why do we want to worry about a valid reason at this point? So if this is the case, it therefore implies that B1 is going to be equal to, in terms of, instead of writing D1, we replace with X1. So it's going to be 2 times angle X1. Therefore, we appreciate that angle A1 is definitely equal to angle B1, because each is equal to 2 times angle X1. Of course, this link is a very weak reason, but I often want to say it so that a student follows, because at times it's easy to not follow this thing and get completely lost. Okay, not a very difficult question otherwise, isn't it? So let's get to the next one. 3.3. Oops. We need to prove that triangle CAY. Now CAY is this triangle, all right, and triangle YBX, which is this triangle right here, YBX. So this is the one. All right, so we're going to be dealing with those two triangles. So how are we going to handle the situation? Of course, we start by saying in triangle K and triangle YBX, what do we know? We know something, that angle A1 is equal to angle B1. This is proved above. Okay, easy. We will say though, however, what is the story? We know that angle, let's just say Y4 plus angle ACY, AC plus angle A1, we should be getting 180 degrees. This is the sum, oops, why am I repeating myself? Sum of 3 angles of triangle CAY. Okay, please, let's be specific, because we can't just make combinations that don't make sense. So this implies we know that Y4 and ACY should be equal, because these are ready, right? So we will then say, well, 2 times Y4 plus A1 should be equal to 180 degrees. Now we need to justify why we ended up with the 2 times here. Where did it come from? We understand that Y4 is equal to ACY, right? Why is that? Because these are angles, opposite equal sides in triangle CAY with ready AY equal to AC. So please guys, try your best to not have things that you say which you cannot provide proof for, and there shouldn't be any assumptions at any cost, at any point, right? So I'm just going to jump to a conclusion. What do I want to say? I want to isolate Y4. This is going to be equal to, remember we transpose this and then divide by 2. So 180 divided by 2 is going to be 90 degrees minus the half of angle A1, isn't it? is going to be angle A1 divided by 2. So this is just simple transposition or operations, whatever you call it. Nice and easy. So what are we trying to get to? We will say likewise, because this is a similar story. Likewise, we understand and fully appreciate that angle Y2 plus angle BXY plus angle B1 should give us 180 degrees. Why? This is the sum of 3 angles of triangle it's YBX. Okay, nice and easy, which implies that 2 times angle Y2 plus angle B1 should be equal to, in fact, what did we say? B1 and A1 are the same. So instead here, we will substitute B1 with A1. This should be 180 degrees. So why is the story? Again, we know that Y2 is equal to BXY, which is angles opposite equal sides in triangle YBX with ready. Please say everything there is to say. BX equal to BY. No manga business right there. So what conclusion can we come to? We can say, well, angle Y2 is itself, so 180 divided by 2 is going to be 90 degrees minus A1, but it's going to be half angle A1. So what conclusion can we make after this? We can say, therefore Y4 from the other triangle is equal to Y2 in the other triangle. Why? Because they are each equal to the same value. And if we prove 2 sets of angles to be equal, the third set falls into place, and we don't even need to mention it. This is too complex. So we can just simply say triangle CAY is definitely similar to triangle YBX. So we can just say angle, because just 2 angles is good enough for similarity. The third one falls into place. This is acceptable. Please don't feel like it's not. Wasting time with the third one, which is too obvious with a weak conclusion, is not good enough. But again, look at the mark allocation. If you've already done a lot of work, don't sweat. But if you haven't, please do include it, because it may just be mark worthy. At this stage, it's not a necessity. There's too many marks to think about and no need to sweat. Okay, let's get to 3.4. We need to prove this ratio. So you can see this is the radius of the smaller circle squared over the radius of the larger circle squared. So in the smaller circle, what is the radius over there? The radius is literally xb or bx. So we can say bx over. Now we're using our similar triangles in 3.3. So this side is opposite angle Y2, and we proved angle Y2 is equal to angle Y4, and the side opposite it is AC. So we can say over AC, these ones make up the ratio, which is going to be equal to yet another ratio. But we're going to choose sides opposite the equal angles in the 2 triangles. So what are we going to say? Well, we know the A's and the B's are equal there. So, and of course, we can see in this ratio we've got CY, so we want that side to come out. So it's going to be CY over. Now, did I say CY? Hell no. We are not to say such treasonous things, are we? Yeah, doch, I think we should say it. Are we not supposed to? We are supposed to say it. Okay, we're going to say CY over. Now CY is opposite A1. A1 is equal to B1, and the side opposite that is XY. Okay, these are the proportional sides of similar triangles in 3.3. So please place reference to where this is coming from. So this implies, what is bx? It's the small radius, so it's going to be r over. AC is the big radius, so it's going to be capital letter R equals cy over xy. Right. Wait a minute. I kind of inverted my business here. No. Remember, I started with a small triangle here, so we must start with xy. Sorry guys. So sometimes knowing how to get this right. So now I've inverted my business here. Not good. So this is over cy. So this is xy over cy. Remember, be consistent. If this is from the small triangle, that must also be from the small triangle. This from the big one must be from the big one. We can't switch around. Alright, so now remember, in maths, guys, gymnastics, we can just do whatever we want as long as we stay consistent when it's an equation. So if we square one side, we get r squared over r squared, which is going to be equal to xy squared over cy squared. This implies that r squared over r squared is, what is xy squared? From 3.1 came out as dy times yc, all divided by cy. Of course, this is the same thing. So what do we know? Again, this square is taken by that yc, and we have our final answer, r squared over r squared is certainly dy over cy. Nice and easy. Okay guys, hope you enjoyed the video. See you some other time. Goodbye.